This looks like a standard algebra problem, but it's actually a classical Harvard University entrance exam question. We have b is multiplied by 4 times and it is divided by b is added by 4 times is equals to 16, and we solve this problem for all the values of b. So by the end of this minute you will know exactly how to manipulate these bases to solve for the value of b like an Ivy League student. So we move toward the solution of this problem. The very first thing we are going to do is, you see that the basis of all these terms are same, so that we add its exponents and it will be written as b to the power of 1 plus 1 plus 1 divided by, in the same pattern we need to take common b from here, and after taking common b we get the remaining values are 1 plus 1 plus 1, and this is equals to 16. So further we need more simplifications and it will be written as this will becomes b to the power of 4 divided by, when you add these ones it will becomes here 4 times of b is equals to 16. And this implies that we move 4b from left hand side to the right hand side and we obtain b to the power of 4 is equals to 4 times 16 becomes 64 times of b. And now we move the value 64b from right hand side to the left hand side and we obtain b to the power of 4 minus 64b, and this whole equation is equals to 0. And now in the next step you see here both of these two terms involve b, so that we take common b from here and we get the remaining values are b cubed minus 64, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write b is equals to 0, and the second case is we write b cubed minus 64, and this whole equation is equals to 0. So this is the first root of the given equation which we get here, and now we rewrite this equation as, this is b cubed minus 64, we write it as 4 cubed, and this whole equation is equals to 0. So here we use the nice cubic formula. You know about that. If we have x cubed minus y cubed is equals to x minus y times of x square plus xy plus y square. So according to this cubic formula, we write the above equation as in this form. So here our first factor is x minus y. We write it as b minus 4 times of b square plus b times of 4 plus 4 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write b minus 4 is equals to 0, and the second case is we write b square plus 4b plus this 4 square becomes 16, and this whole equation is equals to 0. From here we move minus 4 to the right hand side and we easily get the value of b is equals to plus 4. This is the first real root of the given equation, and now here in order to find the other real roots we need to solve this quadratic equation. So we solve this quadratic equation by applying the quadratic formula. So for this we write the coefficients of this equation, and its coefficients are a equals to 1 and capital B equals to 4 and capital C is equals to 16. And we state the quadratic formula as b is equals to minus capital B plus minus square root of b square minus 4 times of AC divided by 2 times of A. So we substitute all the values of A, B and C in this formula, and it will be written as b is equals to, this is minus b, the value of b is 4 becomes minus 4 plus minus square root of b square becomes 4 square minus 4 times of A is 1 and C is 16, and it is divided by 2 times of A, and here our A is equals to 1. And now in the next step we need more simplifications, and it will be written as b is equals to minus 4 plus minus square root of, this is 4 square, 4 square becomes 16 minus 4 times of 16, and it is divided by 2 times of 1 is equals to 2. So further we need more simplifications, and we will get here b is equals to minus 4 plus minus. Here you see that inside the square root sign we have 16 be the common value. So when you take common 16, we get the remaining values are 1 minus 4, and it is divided by 2. So here first we break the square root sign, and we apply square root separately on both of these two values. In this way, this is 1 minus 4 becomes minus 3, and it is divided by 2. So now we break this fraction, and it will becomes minus 4 divided by 2 plus minus. This is square root of 16 becomes 4 times of square root of 3. And we know about that when negative sign appears inside the square root sign, it will becomes iota, and it is divided by 2. So we have this is 2 times 2 becomes 4, and we obtain minus 2 plus minus. This is also 2 times 2 becomes 4, and we get 2 times of square root of 3 into iota. So these are the other two complex values of b. And so finally we have there are four roots of the given equation in which these two roots are complex roots, and b is equals to 0 and 4 be the two real roots of the given equation. So here in the next step, I hope so. All other three roots, these two complex and this 4 is satisfied our given question statement, but I doubt about b is equals to 0, so that here we just verify b is equals to 0, and we left the all other verification for up to you. So here we verify b is equals to 0. For this we need to copy down given question statement. Here it is b multiplied by b multiplied by b multiplied by b divided by b plus b plus b plus b is equals to 2 is equals to 16. So here we substitute b equals to 0 into the left hand side, and we check its behavior, and when you put this here it will becomes 0 multiplied by 0 multiplied by 0 and divided by 0 plus 0 plus 0 plus 0 is equals to 16. Here you clearly see that our left hand side becomes 0 over 0 form is equals to 16. And you very well know about that 0 over 0 form is usually called that it is undeterminate form, or in other words we say that it is undefined form. So if our left hand side is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value b equals to 0 is not satisfied our given question statement. So we call that b is equals to 0 be the extraneous root of the given equation. So this is the extraneous root, and we obtain the solution set of this problem is 4 and minus 2 plus minus 2 times of square root of 3 into iota. So this is the final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.